Let's do this. Improving the Git Diff Algo. I hope this one goes over why they switched from their Menage a Trois merge to Ort. Was that its name? Which led to like a significant reduction in merge conflicts. I don't know if you saw this, but I'm hoping this is real. This developer tool, let's see, this developer tool is 40 years old. Can it be improved? Wait, they're not talking about Git then, are they? Git is not 40 years old. Git is 2005. This era of exponential acceleration that AI has brought forth, the average VS Code or JetBrains developer, they don't say Vim because we all know that when it comes to Vim, Stack Overflow calls them a developer of a certain generation. I will literally suck this egg if they do that again. I feel attacked. I do too. Benefits from Toolkit stacked with modern state-of-the-art components from IDEs to extensions to CLIs. If you stop and consider all the tools you use weekly, which would you guess is the oldest? That is, which tool do you interact with regularly, say an hour per week, that hasn't substantially changed in years? Since IDEs are refreshed every few years, maybe you've guessed that your oldest tool in active use is Git, which was first released nearly 20 years ago back in 2005, or maybe you prefer to code with the classic old-school text editors like Vi. I'm shambling! Bro, Vi is not 2012? Vi is, what, 2 years older than TCP? Stack Overflow, stop using AI to write your articles. It makes you look like a stupid person. Vi is older than Vim. Vim literally stands for Vi Improved. How the hell did it improve it if it came out 21 years later? According to our research, which you probably didn't do, dummy, at GitClear, the oldest tool most developers are still actively using, more than an hour per week, hasn't changed since before the Berlin Wall came down. In 1986, an unheralded Tucson computer science professor named Eugene Myers published his seminal research paper, and the Myers Diff algorithm was born. All right, nice. Few developers today know the algorithm by name, but they can recognize the familiar red and green byproduct of the Myers algorithm, which is the default diff generator of Git, and thus Git platforms like GitHub. Okay. Rage bait. I know they're rage baiting me right now. Seminal. Time machine, okay? I'm new to Vim, currently getting a hand onto Vim motions. That's good. That's good. How does GitHub designate which lines to color red and green? By implementing the formulation of Eugene Myers, who offered what became the canonical solution for representing the difference between the state of a Git repo before and after a developer's Git commit. Oh, nice. Yeah. I always called this earshot. And so I was really used to this algorithm. I've implemented this algorithm once back in the day, and I called it earshot because we had two words that we had to compare, and one of them was called earshot, and I forgot what the other one was called. And so in my head, I've always just called this algorithm earshot, even though I know it's not the name. Why is the person using light mode offended? Yeah, it is possible to improve upon this method. Or did Professor Myers knock it out of the park? New research we've undertaken tests an updated set of diff operators that extend the usual add and delete to include move, update, find and replace, and others. Their goal is to measure whether it's possible to apply a deeper lexicon of diff operators to condense how a commit is represented. Can change be shown more concisely than what is possible nearly 40 years ago? I really hope this is the ORT strategy, because I saw the ORT strategy and I got really I was like, wow, because this only happened, ORT only happened just recently, right? For those that are actually paying attention to when Git talks about how they used merge strategies, you probably have noticed ORT is only relatively new. Our workflow followed tangent lines of investigation, one empirical, one observational. We'll summarize the two sides of the research below. The headline finding should come as welcome news for developers. 30% is less is more. Oh my goodness. The headline finding should come as a welcome news for developers. 30% less is more. Exploring strategies to reduce pull request review time. The research comes accompanied by examples and videos to substantiate the 30% less code to review in pull request finding. Oh, this must be different. Is this a different one altogether? How much time is currently spent on pull requests? Before we could determine how much time could be saved, we had to establish a baseline. How much time is being spent in code reviews in 2020s? According to Code Grip's 2022 online survey of 1,000 plus CEOs or CTO, CIOs, C-suite, and developers. By the way, strange group of people to mix the opinions of. Hey, what are the opinions you want? Well, I would really like if we could have developers And the C-suite talk about merge strategies and pull requests. I just think that's completely normal to have pull requests talk about by the C-suite. Code review is utilized by around 84% of companies. The same survey found that the median developer in 2022 spent 2 to 5 hours per week on code review. 30% of respondents reporting spending more than 5 hours per week on the review. Thus, in a 40-hour work week, more than 10% of the entire week is consumed by code review. Have they thought about what AI is doing? Isn't your whole day spent on code reviewing? Got them. Time spent weekly on code reviews. Okay, so by the way, I'm not going to lie to you. This paper already miscalculated Vi altogether. Poor Bill Joy, R.I.P. Bill Joy. I'm not even sure if he's dead, but R.I.P. his project, which, by the way, Bill Joy did abandon Vi for Emacs, unironically. Very upsetting. But 1,000 developers and C-suite people as your baseline for how long people spend code reviewing, again, is smelling. I swear Stack Overflow they just have crazy ideas. I don't know what it is. The primary correlate of code review time is lines of code to review. The higher an organization's contributor count rises, the more likely the developer's burden of code review will become 20% or more of their total hours available per week. Finding specific opportunities to reduce lines required reviewing. To understand how Git Clear's commit cruncher diff algorithm can generate a more precise diff than Meyer's, let's consider a couple specific examples. The Meyer diff algorithm classifies all code line changes as binary, either add or delete. I thought it also had modified. Okay. The commit cruncher algorithm recognized 3 times more types of line of changed operations: added, deleted, updated, moved, find and replace, and copy/pasted. Examples of recognized code operations here. The latter operation, copy and paste, featured prominently in Git Clear's popular AI code quality research from earlier in 2024. I'm shambling right now. Right now, full ass shamble, which cited by more than 10 developer media sources, including Stack Overflow's podcast. Okay. Research, by the way. The extent to which commit cruncher reduced lines to read versus Meyer's algorithm depends on the content of the given pull request. The more refactoring a pull request includes, the greater the potential savings of lines reviewed. For example, where commit cruncher can express a diff more concisely as follows. Okay, I would like to see this. This actually could be pretty cool. Whitespace changes. One example where Meyer's requires more work by a reviewer is when a code change involves whitespace, like the change shown in the earlier post. All right, let's try to see what happens here. Perform, it does this, but this is with record, and then it appears to be a purely white space move forward. Is that what I'm seeing? This is just doing a with record mapping right here. Is this Ruby? Am I looking at Ruby? Yeah, I am looking at Ruby. I knew it was Ruby because it almost looked like Rust, but then it wasn't Rust, so I knew it was Ruby. Okay, I think I see what's going on there. Okay. This is kind of confusing, this plus and minus right here, and then a plus right here. It also says Ruby. I know, I pointed that out afterwards. Okay, but this is a bit more concise. This is actually pretty nice. Okay, this is pretty nice. Hey, you know what? After me making fun of these people, I now go, okay, this ain't all that bad. No, it isn't. Why not? You said this is kind of confusing with the plus and minus thing. I'm saying that isn't confusing. Oh, no, what I'm saying it's confusing in the sense that, like, these ends and these ends, like, now I'm trying to figure out, does this mean, has this scope shifted somehow to something different? I think if I were to read this more correctly, my guess is what this means is that, actually, I'd have to look at the original. So this end, I'm not sure which one this end actually lines up with. See, that's what's kind of, this is what kind of is interesting. I also don't know Ruby. So, I mean, that's probably part of the problem. My assumption is that this extra width causes an end down here, and so it makes it look a little bit more goofy, right? To my untrained Ruby eye. That's all it would do it. Would tree sitter diffing work? I have no idea. The problem is you're still line diffing, not doing semantic analysis. Interesting. We'll have to see. Anyways, by recognizing whitespace changes as trivial updates, a diff viewer can focus attention on the subset of lines where meaningful changes occur. Fair. Python, though, is pretty important. Another example comes from a pull request comparison posted to Git Clear's YouTube channel. It shows a case where a file was renamed and a block of code that had initially been in the body of a React component was extracted to a standalone function. In GitHub's Meyer-based diff presentation, the change is shown as a new 30-plus line output. Bro, thanks for this image. You know what? I mean, I love this image. This is great. Thank you for this. I don't like to read it. Honestly, I'm not good at reading anyway, so this actually is pretty good. All right, so we have this whole thing. It does this whole business. Dude, honestly, this example is so difficult to understand what the hell's going on. Like, I see that it dropped all these changes on the inside, but still, dude, I can't read this image. It seems cool, though. I think, generally speaking, this idea seems cool, that it's able to see that you refactored out whatever this was, and thus all this inside stuff that was just simply a move, you're not showing. You're just showing this new points of change, which is, hey, these happened, this happened, and then this happened. But I could also see why people could be bothered by that because they want to see or understand what was exactly copied over. I could understand that. I'm curious what it's like when you copy things and move things in kind of like a weird way. Like, can you copy parts and then leave one part down here and see where it goes? I could see this also being very confusing because there's a lot of like semantic meaning that you have to like run through your head. The nice part about keeping things simple is that you could always interpret the code correctly. Whereas this one might be harder to interpret the code correctly. Yeah. I might find it a little bit more difficult. By the way, I had a great time at DEF CON. Thank you. Less excitement. Reviewing pull requests is precisely what the average code reviewer seeks. By aligning the no-op changes to the reallocated method, the commit cruncher presentation conserves a reviewer's attention for lines with more substantive content differences. Which is true. If you know that none of these things have changed, they've simply moved, then that does make more sense. Perhaps GitHub could add that as just like additional information, like with a little M. So you still see that it's all green. These are all new lines, but they're actually just purely move lines. Could be nice. Instead of taking away that information altogether. I kind of like the simplicity of it. But to be honest, you weren't interpreting the code. You were interpreting the change only. So I guess it's kind of nice to hide the lines that haven't changed. True, but there is a lot more change than this, though. You have moved the code to execute somewhere else. So it's like a compressed view, which may or may not be great. Incremental updates. Another line reduction opportunity is presented when lines received an incremental modification, like the trivial change from a React commit. Okay, export off-screen visible, detached, passive. Okay. Oh, you added a line up top? Okay. Oh, I see that. Yeah. You just added one line up top. Oh, detached was added in the middle. Okay, I see. Okay, yeah, so you have to put semantic meaning on these things being moved. This is green is new line, blue is moved? Okay. I mean, it is kind of nice to know that things... Well, no, it's not precisely moved. Okay, so actually this is very confusing. Actually, I think this is horrible. Okay, nope, this is not good. I take it back. This is horrible. Look at this. Visible is binary 0-1. Visible here is binary 0-0-1. They are the same value. Correct. They are the same value. But its physical representation has actually changed. Same with this one right here. Off-screen passive effects actually has had a physical value change, right? But this one, like, there's so much meaning going on here. You have to realize that you have this extra thing added here that wasn't there before. And this one's been changed. I'm not sure how, like... The amount of little bits you have to pick up by highlighting can be missed by the color scheme itself. Like, I didn't even notice these changes at first. You have to be non-colorblind, too. Yes, you have to be non-colorblind, and there's a lot of thinking, right? These little bits, these little bits, right? Oh, yeah. This is also really crazy that this exists. Who put this in here? You know what? Wait a second. You're right. What the hell is that? What the hell is even that? Why is there comments? Just give me the code. To get around formatters? I'm just going to be real for a second, which everybody already knows this. I hate the JavaScript ecosystem sometimes. I just hate it. Formatters and linters are just not good. Yeah, I go back and forth on this all the time. Like, I like the idea that Go just says, hey, there's one way to have Go. Like, that is nice. But Go's formatter also pisses me off that it does plus, it squashes pluses. It does this right here. It does this thing right here. I hate that. Yeah, I just hate it. I hate how Go uses tabs. Yeah, I know. See, this is the problem about formatters. Anyone that has an opinion is immediately wrong in somebody else's eyes. And now we have, instead, so this is how you get around someone else's opinion. Because you know somebody else on their team said no white space alignment. And this person said, oh, hell, I'm not going to have white space alignment, and made their own white space alignment, right? Here's my opinion about formatters. Formatters is what design by committee looks like, where nobody gets the style they want and everybody is a little bit upset. And maybe that's why it works, is because everybody's upset about it. JS Prettier maintainer wrote, he is opinionated, so it's understandable. Yeah. It's just designed by committee, and it's the worst. It's always the worst. Go format style is no one's favorite, yet Go format is everyone's favorite. See, the thing is that you could have just stopped at the comma, and that would have been a correct sentence that that could have been uttered. Go formatter style is no one's favorite. The end. Because it's not my favorite. I hate it. I actually hate it. Anyways, whatever. There's literally no better ways to get somebody to bike shed than talk about formatters. Okay, I actually feel bad that the Prettier guy one day woke up and he just decided, you know what I'm going to do? I'm going to make an open source project to make files look prettier and have a standard. Like, imagine waking up and thinking that and then writing it, and then for the rest of your life discussing the indentation of ternary operators. Because people in React land won't stop using so effing much ternary operators. Consistency is a good argument. I just don't even believe it's a good argument. I literally could care less what your code looks like. Like, other than if you're just chaotic, right? Dude, relax, dude. I can't relax. I cannot relax, okay? I cannot relax. Okay, here, hold on. Ternary, improve. Oh my gosh, we're going here. We're completely distracted. Prettier. Okay, we're looking at this. Look at this. Look at this. Somebody decided that this was reasonable. Oh, where is it? Where the hell is this? Where the hell is this? Someone decided that this should be written, okay? If I saw this, if you just came up to me like that, I would punch you in your mouth. This is stupid code, and you are stupid for writing this. The end. That is it. There's no, it depends. There's no, well, you know, some people find this prettier. No, it's not. It's not okay. This isn't okay. That's never been okay. I don't care that you can solve FizzBuzz like that, okay? It's not okay. This is bad. Stop it. Stop it. I don't need to contain that much shitty state in my brain just to understand your crappy code. I want to see a Hadouken. Hadouken! Right in the middle of this, dude. Because remember, ternaries, you actually have to push state in your brain. Whereas if you just have if statements, you get to do linear state traversal. This is push state traversal because you have to go, okay, if these two things, then we got to do this. Okay, else we do this, but then else we do this, and then else or else. Right? Like, how many else's do you need? There's so many else's, I'm like pushing my state down. This is the more prettier version of it. So this is the suggested improvement right here. Again, if I ever had the chance to review this code, I would gently shut my laptop. I'd place it to the side, nicely. I would then walk over to my coworker's desk. I would reach for my golf club, left-handed, of course. Take it off, nicely just take off each individual one and get it nice and far off, pull it off, do a couple loops, and slap that bitch! What are you thinking? Oh my gosh. I am so triggered right. I cannot believe how upset I am. I am so angry. I can't even believe it. HR session is not, no. HR session, no. Yeah, I will. Yeah. No, yeah. Sure. Yeah, no, I understand that you could use a ternary, Karen, but here's the deal. I don't care. I'm wearing a glove to the office from here on out because when that moment happens, Karen, I am gently replacing my left-handed golf club with a 5-fingered slap to the face, okay? You got that, Karen? And if you submit code, you're getting slapped too. Got it? Okay. What did the 5 ternaries say to the face? All right. Anyways, weaving the changes together. Commit Cruncher employs another more subtle difference in how it derives which lines change compared to Myers. To understand this difference, consider a pull request that includes a set of commits, A, B, C, being proposed for merge. The Myers diff algorithm works by inspecting two inputs, the repo state before the commit A and the state after commit C. The only information that this diff algorithm has available to construct a visual diff is the state of the repo at 2 points in time. Consider a case where B commit renames a file, followed by C commit adding and removing a few lines from the renamed file. A comparison that considers A, C would show the before and side, on the before side the pre-renamed version of the file, a renamed file. Oh my goodness, that's why. Okay. Okay. A comparison that considers only AC would show on the before side the pre-renamed version of the renamed file as deleted lines. On the after side, the hundreds or thousands of lines from the renamed file would be presented as if the file had been newly created. In contrast, Commit Cruncher employs the more computationally intensive approach of the following each changed line through each commit that it appears within to build what is labeled a commit group. I think I need to see a real version because I don't understand what you're trying to say. Way too dang. Dude, this stuff is way too dang. It's a clusterfuck. Yeah, this one's really hard to understand what is going on here. Just hear me out here. I feel like the idea of attempting to reduce the amount of visual information to be replaced with semantic information is almost like understanding a really simple programming language. I think this could honestly greatly increase the confusion of larger changes. Like, I'd like to see this in action. Maybe this makes more sense once you see it. You know what I mean? Like when you see it, these no-ops, you're like, oh, this makes sense. But this feels like you could just get things wrong. There are a few benefits that emerge from doing the added work of traversing each line through the entire commit history. The one benefit is that when hovering on the line, the developer can access a historical record of the commit messages, which often elucidate why a particular line evolved into its final form. Damn, final form. From Git Clear's video. Again, dude, dog. Quit recording from a potato. This is screen capture. What is this resolution? 480? What is this, a CRT? A CRT you're recording from? Like, what is this? You're zoomed in? Oh, that's the problem? Okay, yeah. Oh, you're right. That totally made it better. Here, maybe I need to be zoomed more out. Okay, yeah, there you go. That's pretty clear. I'd say that's pretty clear. So that's approximately the level. So about 480p. Another benefit is that when a line undergoes multiple changes, like being moved and having a find and replace added, Commit Cruncher can still show the reviewer the original location of the multi-updated line. This means less uncertainty about how this line will perform in production environment. Is this true? I mean, I like this idea of like showing this thing right here of how it was traced through in the commit message for it. I don't know. Wait, is empirical is that just incorrectly spelled? Okay, empirical. Yo, bro, that's empirical. You wouldn't understand. This is empirical. To assess the real-world impact of using Commit Cruncher diff algorithm versus classic Myers Git Clear analyzed 12,638 pull requests that it processed during the second half of May 2024. The pull request diffs were processed by Git Clear and compared to their GitHub equivalent. The contributing repos were about 25% popular open source projects: React, VS Code, Chromium, TensorFlow, and roughly 75% SaaS customers who had opted into anonymizing data sharing. Git Clear used the GitHub's API compare endpoint to capture the count of added and deleted lines that GitHub would show for each pull request. Then it recorded the count of changed lines per pull request as derived by Commit Cruncher. 28% fewer lines to review. Our metric for the comparison was the number of green or red highlighted lines in either classic Myers diff used on GitHub and elsewhere versus the highlighted lines on Git Clear using updated diff algorithm. We lumped add, remove, and others into a single value, and that's what the code reviewer would see. Here were the 12,638 pull requests with an average and median change line counts for the variously sized pull request. All right. Okay, so I'm going to be real here, okay? This means nothing. at all. This is a nonsense piece of research. Because yes, you're right, it's 28% fewer lines to review, but there's also semantic differences that you have to review. How complicated are those individual 28% less? All I'm hearing is that there's 28% fewer pieces of data for me to look at. That does not mean it's easier. It just simply means there's less. You know what? Perl can pack just an absolute punch to the dick when it comes to the amount of semantic information in a single line. That does not mean one needs to be punched in the dick all the time. Okay, I get that it's possible. It doesn't mean you need to do it. Pack a dick, Perl. Dude, my editor, by the way, no idea what he is saying right here, okay? I don't know what this means. Is this like some sort of UFC term? Is pack a dick, Perl, like some sort of jiu-jitsu move that I'm unfamiliar with? Flip? All right, so let's move on. All right, hold on. I guess we can look at this. The median difference between Myers and commit cruncher ranges from 27% to 31%, depending on the total magnitude of the change set. This implies that updating Git Diff processing tools can reduce the volume of lines required reviewing by almost a third. A detailed description of the database queries that were used. Yeah, again, this is just purely a nonsense metric. It has no meaning in any. Oops, sorry, pardon me. Oh, baby. This has absolute no real world importance. Just like saying you can express something in one language in fewer lines than another language, it doesn't mean that it's any more or less clear. We've all read some atrocious JavaScript or Python before. It didn't mean it's clear because there's less lines of code. Interview compare method. Let's see. Are shorter pull requests more prone to miss bugs? While the raw line count, here, hold on, let me zoom in a little bit because I like this zoom. While the raw line count suggests that commit cruncher processed pull requests will require fewer lines to be reviewed, lead developers, CTOs, and VPs of engineering, CTOs and VPs, my favorite people to go to when it comes to code reviews, may fairly wonder if there are less desirable changes coupled with a new diff processor. To research these questions, 48 developers, research participants were recruited randomly from the web platform Code Mentor. Each participant was assigned to review 2 different pull requests in a programming language familiar to them. Each pair of pull requests alternated which Git platform it was shown on. For example, the first participant would review PR1 on GitHub and PR2 on Git Clear. The second participant would review PR1 on Git Clear and PR2 on GitHub. The research provides tabular results for these 48 developer interviews, collecting data to evaluate. Do reductions in lines to review actually translate to a corresponding reduction in real-world time to review? Does reviewing the pull request in less time correlate with negative or positive impacts to percentage of bugs discovered? A study by Bacelli and Bird that supports the contention that when reviewing code, most understanding and attention is spent on in search of finding defects. Okay. Okay. Statements from the Git Clears survey participants support this interpretation for code review motivation. The most difficult thing when doing code review is understanding the reason for the change. Understanding the code takes most of the review time. A successful code review submission, the author is sure that his peers understand and approve the change. To shorten the code review process, a tool needs to accelerate the rate at which a developer evolves from encountering code to contextualizing it, to evaluating whether it satisfies the author's goal. Okay, so they're saying they can understand code faster. C# mentioned! Okay. So I guess the next thing is, was there bugs within this code? The 48 people that were shown these various codes in their various languages, were these samples in which made Git Clear the most objective winner just by the very nature of what they're shown? Like there's all sorts of questions going on here. I would personally consider a recording of 48 people being effectively like making up a statistic. You might as well just say anything you want. It doesn't really matter. Second off, the variation of the code being shown leads a huge potential problem here to game the statistics. Third, there are so many confounding factors in real-world code reviews, meaning that the experience of the developer reviewing code versus the experience of the developer writing code versus the familiarity with the language itself versus familiarity with the problem itself. There is so many confounding factors that you could throw into here that this could vastly change. It's not even that it's within maybe like a 10% error or a 15% error. This could be just massively different. The metrics we need are the rate of production impacting bugs introduced and time spent on PRs. Yes, there you go. And stop asking C-suite shit about this. There you go. That's the real thing. Even that is so hard to measure, right? Because you can't even do an A/B test, meaning that you can't have two companies reviewing the same set of changes and seeing which one produces more bugs. You'd have to have, millions of developers over a long period of time through many companies doing this type of A/B tests, right? Like, it is... The amount of variations you will get and the ability to actually suss something out is virtually impossible, especially on something so small as this. Wait, are you giving me more food? You've given me so much food. People are watching this in chat and wondering, are you fattening me up?
I just made too much.
My wife's trying to make me thick. Just like this smoothie she's giving me. Sorry, there's a little F. There's a little F. There's a little F. Refresh if possible, Sorry, dude. I swear it's either Twitch or OBS. It's not me. Because during this whole time, I'm seeing your chat run, music's playing and being downloaded. I'm having no actual Fs at all, right? Milkshake ASMR? Yeah, we could do that later, baby. Oh, baby, what do you mean later? What do you mean? What do you even mean by that? I could certainly do this. No, stop. Yep, and I'm out. Let's go. Keep it in. Mouth noises. Yeah, there you go. All right. There you go. Code comprehension metrics. Git Clear's research found pull request comprehension within the margin of error for Git Clear and GitHub reviewers. Question accuracy Git Clear. Question accuracy GitHub. Question accuracy difference. Did they really just do the math for me? Bro, did you really just add this yellow line for the difference? Why would you map the difference here? Anyways, question accuracy percentages were less than 5% different. A statistically insignificant benefit was found in favor of commit cruncher diffs when evaluated across the entire pool results. Yeah, but it's already bogus to begin with, so maybe you could have actually had a benefit if you would have done more research. Oh my gosh, I just want to throw punch these people so hard. I'm just so angry at this. The raw data of the evaluation metrics for each individual session was plotted using a scatter chart, comparing question accuracy. By the way, this sounds like an 11th grader paper when they're handing it in. They're describing what this is. Well, actually, the scatter plot, which is linked directly below this current paragraph that I am currently writing, will be available once you scroll down to see it. This will help me increase my word count, thus meeting the requirements of this paper. Comparing the question accuracy scores against the code review duration, as seen in the figure below. Got him. The code review duration decreased is visually outlined by the increased frequency of blue Git Clear dots on the left side of the chart. Explain that one. I'm pretty sure if you ran some sort of Man Whitney on this, I'm not sure if you're winning. I'm pretty sure if you ran even a t-test, bro, this thing's coming out like 30%. This is literally off the charts. Let's see, on durability of status quo. Perhaps the most substantive question that comes to mind while reading this research: how has diff viewing evolved to be more homogeneous than any of the developer IDE, Git platform, or system OS, compared to the innumerable programming languages that have come and gone in the decades since the Myers algorithm was created? How did so many products converge on a solution developed 40 years ago? We offer two ideas on this puzzler. I will offer mine at the end. We'll see. The first possibility is that most developers don't even recognize that it's possible to represent a diff without Myers. Since diffs have looked the same since their career began, nobody thinks to go looking for other options. The second lesson is that Myers is much cleaner algorithm than any successor would be. Choosing Myers offers an instantly available multi-generational tested means to show a diff. And when it comes to reviewing diffs, getting every line right every time is incredibly important. While Commit Cruncher shows significant improvement over Myers in this research, it relies upon a set of intuitive iteratively tuned heuristics. My goodness, please. Oh my gosh, Flip always takes, I kid you not, guys. My editor, he's so adversarial. Every time I mess up on a word like that, he keeps it. And I swear he's handing it to the guy that are making those Rick and Morty things. And so now the Rick and Morty guy just constantly finds these things and makes his own Rick and Morty version of me going iteratively. And then it's just like, there I am, being Rick and Morty, being a dummy every single time. There's entire reels of me looking stupid, and I swear it's all Flip. Flip W? No. This is why you're the first person I'm forgetting. None of the large Git platforms can afford to imperil users' trust as they iterate on a more granular representation of what changed within a commit. Much like all source control providers herded to Git once it was proven reliable at enterprise scale, no single company is likely to evolve their diff tool until they have strong incentives to do so. As future research corroborates that a savings of more than 20% is possible in pull request review time, the current stasis may end. All right, so I'm going to offer a different possibility. Here's my different possibility. While I was working at Netflix, by the way, I work in Netflix. I don't know if you know that. I worked at Netflix for a decade. I use NeoVim also, by the way, and I used to program in Rust, and now I quit using Rust. I'm a reformed Go programmer. Anyways, during my time there, I needed to try to find ways to be able to deliver a clear signal as to memory and using too much memory on television devices. My first thing I built was called, I don't even remember what it was called. I wrote it in Go as my first Go program ever, and I just wanted to try out Go. And all it would do is it would take your pull request, and it would run it through the memory test runs 100 times, and then give you a nice organized version of it. So you can see like a CDF or an inverse CDF or all the fun stuff, right? You could actually just see like your data, your mean, your median, and then you could compare it statistically, say with like a Mann-Whitney test, has your set of points changed against the master set of points. So I'd run it 100 times with what was currently in there and 100 times with your new change, and then compare the points. It makes sense. That proved to be a very valuable thing. In fact, that was adopted by TVUI and is still being used when I was left. Like, that was a really good one. The second thing I developed was this thing called the memory analyzer. And what the memory analyzer would do is I hooked into the JS Core JavaScript engine, and upon every single allocation, I'd find what line it was, and I'd find what type of memory it was, and then I'd take that memory and I'd save all sources and source maps, and then I'd actually take that and wire it back. So I could say, hey, your usage of, say, RxJS has increased memory 4x comparatively. You're using a lot more RxJS. What is going on here, right? It could tell you exactly which libraries are the ones that are behaving poorly. The first one was a massive success. The second one was an utter failure. Let me explain why. The first one gave a clear signal that you are better, worse, the same, and with statistics. The second one was effectively attempting to shortcut very simple research. By simple research, I mean you could just simply run, say, any of the memory profilers by V8 memory sampling, right? It takes a sample every 32 kilobytes and gives you a nice graph and all that, and you can just see there it is. But by giving way more information, it actually leads people into potentially incorrect places. It doesn't actually help them solve the problem, and it doesn't actually make anything different. It just simply makes more information. And so I tell you those two things because this is what it reminds me of, is that the first one gives you just the information. These things were removed. These things were added. Here you go. It was beautiful. This other one tries to be pretty clever and is like, well, this one was actually updated and this part of the line was updated. Hey, these ones they technically weren't really updated because it was white space, so it doesn't really matter. So you can just see them right here. It's okay. It doesn't really matter. And, it tries to do like this midwit curve of everything. And I just don't think it's going to be successful. That's just that. Conclusion. The evidence presented herein raises new questions for the oldest tool still widely used by contemporary developers. The implication of 28% drop in code review time could be significant. Scale the 2022 Code Grip Code Review Survey result to a 10-member team, and the math works out to about 50 hours per week spent code reviewing. If the combined developer and manager salaries of $150,000, then a 10 developer team invests around $16,000 per month of salary toward code review. Haha, thinking that developers only work 40 hours a week. What a loser. Oh, man. That's funny. This doesn't include the difficult to measure but familiar to any developer time needed to context shift in and out of code review mode. A reduction of the magnitude observed here would mean that a 10 developer team could reallocate 40 hours per month for more coding. See, again, you just got done defeating that argument with this right here. If anything, any benefit that results in one extra PR would probably dominate with context shifting, right? Man, shit don't work like that. It never works like that. It doesn't work like this. You can't just do that. Considering that code review is often one of the most unpleasant and high willpower chores included in a developer's responsibility, the morale improvement gained by reducing code review time may rival the gains in time saved. The full text and citations of Git Clear's latest research is available to download. 30% less is more. Exploring strategies. There we go. Okay. It just needs to be bigger research. I'm not saying that this isn't true. I have a really hard time believing more semantic information encoded in a code review will make bugs happen less often. We as humans are already notoriously bad to details. And so this idea of encoding more information, I just cannot imagine it actually being better. But I could be wrong. He's right. Developer time is expensive. Reduce stand-up time. Bro's right. Bro is right. I don't believe that. Yeah, I don't believe it. I currently don't believe it that this would change. This would have any change in actual work. This is super interesting. This is super interesting. Okay, hold on. Their arguments really feel like this was made with an assumption that they are right, without measuring any meaningful metrics, phrased to be convincing to C-suite. This is how I feel, because you had contrived merges in which you tested people. So I feel like the contrived merge could very well have been created that it's the worst case version on GitHub and the best case version on Git Clear. Like, right? We don't even know. There's no variety. There's no version. There's no me dropping that 1,000-line change, right? Write better code, Primogen, that will fix it. Good luck. One person's good code is another person's bad code. That's the real truth of the world. So when people talk about like having maintainable and readable code, what they're saying is that you need to write it the way I want to see it. It's so much code looks horrible and some people love it. Just saying. There's times where there's actually bad code. There is objectively bad code, like code that creates a bunch of functions and then execute those functions inside the functions and has a bunch of closures and stuff. That's just hard because you have to like map your head around all these different closures. Reasonable. We can all agree to that. A function that has an inner function that has an inner function probably could have been written differently. But most code, not that bad. Logged in from YouTube to say this felt like an ad. It felt like an ad. Largely, it felt like an ad. My guess is that someone's trying to sell something here. And they're just trying to go, trust me, bro. Bro, just trust me. 1 more minute saved is 1 more minute of development. That's how it works, bro. Bro, don't worry. You're going to get 40 more hours from your 10-person team a month. Bro, that's like an extra week of development time. Bro, you don't even need to hire an extra developer because I'm going to give you so many more hours. Bro, think about this, bro. Bros only program 40 hours a month anyway, so like 40-hour a month saving is literally just like 1 extra programmer. Bro, trust me. Anyways, the name. Please, you don't publish research that is this small, okay? Like you really, especially on something like this, okay? Because I just want to be real here. I'm going to be real. Get clear, you may have a great idea, and this may actually be fantastic, and you may have actually just built something that a lot of people could benefit from. Or you might have just built something that semantically overloads a bunch of information, which leads to the further enshittification of the internet. And you are sitting here promoting something that you actually haven't done real research on. Now, by writing such a bad article, this could influence a bunch of VPs and C hashtag O's in which they go off and enforce this to happen. And then your idea, which was improperly vetted, called as research, could then be foisted upon a bunch of developers, in which could lead to further and more bugs due to, again, semantically dense information during a code review in which you're already battling trying to understand where bugs lie. And then this could further lead to the point where all of our lives are generally suckier. But Git Clear does make the bag, and so maybe that's the reason why. God did not intend for enshittification to happen. We are supposed to till the world and make it nice. We are supposed to bring chaos, or we're supposed to bring order from chaos. It feels like right now you are promoting chaos in my heart, and I'm very turbulent. I'm free falling in some turbulent seas right now, and I don't like this. Repent, sinner! Oh my gosh. Oof. Oh. Oh. I'm getting freaked out right now. Okay, the name is the Primogen.